Hi, in today's experiment I'll be making honeycomb toffee in order to understand the Maillard reaction that happens when we caramelize the sugar, as well as the importance of sodium bicarbonate in foaming the sugar. The materials I'll be using include a pot, a baking sheet that I lined with parchment paper and greased with oil, a sugar thermometer, a whisk, 3/4 cup sugar, 2 tablespoons water, 2 tablespoons corn syrup, and 1.5 teaspoons of baking soda, which is just sodium bicarbonate. First steps in this reaction include pouring the sugar, the corn syrup, and the water in a pot and whisking it over low heat until all the sugar is dissolved. Corn syrup is essential to add because it is made up of glucose that can interfere with the sucrose of the granulated sugar that wants to recrystallize during the caramelization process. Although the overall caramelization process removes any water from the molecules, a little water is necessary to add to coat the sugar and ensure it didn't get scorched by the bottom of the pot. The mixture was whisked until all the sugar dissolved to really mix together the ingredients and make sure no large sugar crystals were left by heating unevenly, which would provide a nucleation site for more sugar crystals to form. This would disrupt the caramelization and create a rough and grainy texture in the honeycomb. The whisk is removed once all the sugar is dissolved because the whisk itself or any other stirring spoon could also provide a nucleation site for crystal formation. Once all the sugar is dissolved in the mixture, you can put the sugar thermometer in and leave it alone until it reaches 300 degrees Fahrenheit, which is the hard crack stage for sugar. The hotter the temperature that the sugar is heated to means the more water that gets evaporated and therefore the harder the candy. The hard crack stage occurs at 300 degrees Fahrenheit and is the hardest the candy can get, which is what we are aiming for in order to get a nice and crispy honeycomb. As you can see, once the sugar reaches 300 degrees Fahrenheit, it has a deep caramel color. It's important to remove it from heat immediately in order to not overheat it, which would cause the sugar to burn and have a bitter flavor. The sodium bicarbonate is now added and whisked vigorously to combine the ingredients, but not over-whisked in order to keep many of the gas bubbles trapped in the sugar. And so right when it's done being incorporated, I want to pour it into the mold without it splashing, so being very careful because this is very hot, and leaving it to sit for a few hours to cool down. Once the hot sugar is poured into the baking pan, make sure not to smooth it out with the spatula to ensure the carbon dioxide gas bubbles don't pop and keep the honeycomb nice and bubbly in the middle. We are done with the sugar. So we're back after a couple hours and the honeycomb toffee has cooled down enough to be brought out of the parchment and broken into small chunks. Now breaking it, you can do with anything. I'm going to use a rolling pin just for easiness of it. And it should be able to basically just crumble in your hands. And this is what the inside looks like. You can really, it's cut up into chunks. You can really see the CO2 gas bubbles that were formed by the sodium bicarbonate decomposition. These gas bubbles were held by the shape by the sugar recrystallizing around these gas bubbles. And the recrystallization step of the sugar was very important because it happened over a very fast cooling period from going from 300 degrees Fahrenheit to room temp, very fast. So only small crystals were formed and it made it a very fine texture that's easy to break and a smoother texture in the mouth, which is different than what would be found from a longer recrystallization process, which would cause bigger crystals and more grainy texture in the mouth that wouldn't be as easy to break apart as this honeycomb is. Now that the honeycomb has been made, we can look back at the main chemical concepts of this experiment. Like I said at the beginning, the main purpose of making honeycomb was to study the Maillard reaction by seeing the process take place, which is the caramelization of the sugar, as well as understand the importance of sodium bicarbonate in creating air bubbles throughout the toffee. The Maillard reaction is many small simultaneous chemical reactions that occur when proteins and sugars in food are transformed to create new flavors, aromas, and colors. It is also the non-enzymatic browning of food. This occurs by the reducing sugars and proteins due to the impact of heat. Caramelization is an example of the Maillard reaction in which there is also a non-enzymatic browning of food. In the caramelization process, water is removed from a carbohydrate, in this case sucrose, due to granulated sugar just being sucrose. Sucrose is a disaccharide made up of glucose and fructose. This disaccharide is broken down to glucose and fructose in the process known as sucrose inversion, which occurred in this reaction due to the presence of heat. The sugar molecules lose water as they react with each other to form difructose anhydride, while more water is lost due to aldoses isomerizing into ketoses. These sugars polymerize to form 3 caramel molecules, which give caramel its color and taste. Now, after we added the sodium bicarbonate, we saw the formation of foam. Foam is a liquid substance in which air bubbles are trapped inside it. The heat causes the sodium bicarbonate to break down and release carbon dioxide as a gas. The gas creates bubbles in the honeycomb by getting trapped in the sugar. The foam then recrystallizes during the cool down period to create the solid honeycomb that's both yummy to eat and fun to make.